Hello, I'm Dr. Semyonov from Institute of Biophysics, Krasnoyarsk. I'm going to talk about DNA methylation. I'm going to talk about non-canonical base pairs in DNA. And I'm going to talk about DNA cleavage by ultrasound. This method helped us to understand some of the mechanisms of epigenetics.
This is cytosine. The proton of the amino group in cytosine can migrate to another nitrogen atom. This is tautomerism. It is the amino form of cytosine. Cytosine creates Watson-Crick pairs with guanine. Aminocytosine can create wobble pairs with guanine. When cytosine is converted to aminocytosine, the Watson-Crick base pair is converted to a wobble pair. This is the double helix of DNA. The sugar phosphate backbone of DNA has a regular structure that does not depend on the base sequence. The displacement of the bases leads to the distortion of the sugar phosphate backbone. The bonds near cytosine are additionally strained. Ultrasound can cause DNA to break down. Bonds are broken more often after cytosine. We hypothesize that GC wobble pairs in DNA are responsible for the increased frequency of cleavage. The bond in the CpG dinucleotide is broken most often. It is important to understand the mechanisms of epigenetics. If we add a methyl group to the cytosine molecule, we get 5-methylcytosine. 5-methylcytosine forms the amino form a little more easily. As a result, a wobble base pair is more often formed in the DNA double helix. As a result, the bond after 5-methylcytosine is broken by ultrasound 1.5 times more often. We assume that wobble base pairs are epigenetic markers. Regulatory proteins can recognize wobble base pairs by attaching to the free amino groups of these pairs. Thanks for your attention.